All right, today in algebra we have, whoops, pardon me. Today in algebra we have section 3.5 and we're doing percent change and error. All right, so first up, percent change. We have a formula for percent change. So it's always going to be our amount of change over the original, okay, and then times 100. So again, it's the change over the original. You're going to see me write it like this, times 100% because it's a percent change. If you get the decimal and you write it by 100, that's okay, or write it as a percent, that's perfect. So let's look at some examples. An increase of $10 on a $1,000 computer is going to be 10 over 1,000 and then times 100%. So that's a 1% change, okay? A 1% change. An increase of, so another increase here, but this is $10 on a $5 notebook. So again, our change was $10 on a $5 notebook. That was the original price. Times 100% is 200% change. Okay, so that cost increased by 200%. Okay, so instead of being $10, now it's 15. Okay, so let's get into it. A baker decided to raise the price, so that's an increase, of a loaf of bread from $3 to $4. The new price resulted in a large drop in sales. So he reduced the price back to $3. So now we reduced here, so that's going to be a decrease back to $3. Determine both the percent increase, that's the first thing, and the decrease. So that's the second problem. So we have two problems here. All right, so first of all, remember we need the change over the original. So let's say this is the increase, okay? So the change over the original. Well, it went from $3 to $4, so the change is $1, and the original price was 3, so 1/3. Okay, and so that would, again, if you don't multiply this by 100, like this decimal would be 0.33, and you're like, wait a minute, I know that that's 33%. That's fine with me. Okay, 33%. Or you can say with the formula 1/3 times 100 in your calculator is going to give you 33, and you put your percent label on it. However you do that, I'm fine with both of those. Okay, so I'm going to draw a line, and let's look at our percent decrease this time. So they raised the price to $4, and now they decreased it back to $3. So the change is, because we're still looking at the change over the original. So the change is $1. This time it went down $1. The original price this time is $4. So 1/4 equals 0.25, which is 25%. So that's kind of interesting, right? That we had a 33% increase, but when they dropped the price back down, it was a 25% decrease. You're probably like, what? It should be the same. Well, it's not because our original cost is different. So the percentage changes. Kind of interesting. Okay, so let's try the example 2. Last year, 1,056 people voted in city elections. So let's write, underline, 1,056 people. This year, only 912 voted. Find the percent decrease, so they're telling you that it's a decrease, to the nearest tenth of a percent. Okay, so we need the change over the original. Okay, so I'm writing this to get that formula ingrained in your brain. So to find the change, though, okay, we're going to take 1,056 and subtract 912. Hopefully you guys are maybe in the habit of bringing your calculators. So you do that math, we get 144. Okay, this is the change. right? This number here is the change. That's what's going to go in our formula. So we're going to have 144 over the original number of people. Well, that's last year's vote. So 144 divided by 1,056. And that equals about 13.6% because we rounded to the nearest tenth. So 13.6%, and remember it was a decrease, percent decrease. Okay, so looking at it a little bit differently. When a quantity increases by a percent, you're going to add the increase to the original amount. So let's think about this. If we have $50 shoes with 5% sales tax, let's say that's $2.50. The total bill is $52.50 because we added the $50 to the $2.50. Okay. Now the other thing, it's kind of a shortcut. The total can be calculated directly because the total is 105% of the original. Okay, it's 105% because the 100% is the cost of the item. The 5% was the tax on the item. So instead of calculating it and adding it to it, we could just say it's 105% or 1.05 times the original amount, so times 50. So 105%. And that's what this says. An increase of X percent means the new amount is 100 plus X, whatever that X is, of the original. So it can save us a little bit of time in calculating. So I'm going to go on down to when the quantity decreases. It's the same concept, but I've got to move my paper down so we can see it. Okay, so when the quantity decreases by a percent, we subtract the decrease from the original amount. So an example, if we have a $60 video game with a 10% off, which is $6, the total bill is $54 because we did 60 minus 6 equals 54. Okay, the total can also be calculated directly because the total is 90% of the original amount. Okay, so that's like taking, so instead of it being, it was the cost of, I lost my pen, just disappeared on me. All right, it keeps messing with me. Now my paper's moving. That's pretty fun. All right, let's see if I can get it back. There we go. And we're back. Okay, so it could be calculated as 90% because the original item is 100% minus the 10% discount leaves us with 90%. So we could take that cost of $60 and multiply it by 0.90, which is 90%, and it'll get us 54. That's a nice little trick that you can use in your calculator. And the way that that's talked about here is that decrease of X percent means the new amount is 100 minus X of the original. Remember, of means times, and so we would multiply by the original. So let's try this on a few on the back. Okay. So if the city of Woodridge is projected to grow 7%, so it's going to grow, so that's an increase, 7% over the next decade, and its current population is 35,000, how many people should be planned for at the end of the next 10 years? Okay, so it's going to grow by 7%. So we're going to take 100%, we're going to add 7 to it, and get 107%. And the decimal for that is 1.07, right? Like that's going to be helpful. So we can take 35,000, that current population. So take 35,000, that's a comma in there, and multiply it by 1.07. And that's going to give us our new population, which is 37,450. Now, you don't have to do it this way, okay? That's the other thing. You could take and do it the way we kind of started, or you could find 7% of this, okay, because that's a feasible thing. So you take 35,000 times 0.07 for 7%, and you get 2,450. So you don't have to write this down if you don't want to, but you can check it out. All right, now that I have this number, we talked about how we have to add that to the original. Because if our population is increasing, and it was 35,000, it's not going down to 2,450. We have to add it. So we're going to take 35,000 plus 2,450, and we're going to get 37,450, which is the same thing I got over here. These are the same. I just have different strategies to get there. Okay, that is perfectly fine. There is more than one strategy to get there. All right, let's look at example 4. Through dedicated training, a runner was able to decrease, okay, so we're looking at percent decrease, his time in the marathon by 13%. I feel like that's a lot. To a time of 2 hours, 47 minutes. What was his time previously? Ooh, okay, so we want to know his time before. All right, so this one might be a little bit trickier because he increased his time, or sorry, he decreased his time by 13%. Okay, so if we know that, that's 100 minus the 13, so that's 87%, or 0.87 as a decimal. All right, and in order to solve this one, we have to think about it a little bit more. So he decreased his time by 13% to this time of this number. But so this is like his final, right? This is his final or his new number. It's not the original. So we're going to have to take this decrease, because we don't know what his original time was. So we're going to have to do 0.87 times his original time equals the 2 hours and 47 minutes. But it's also helpful to have that in 1 unit. I'm going to erase this a little bit. We want that in 1 unit. So we want to put equals 167 minutes. We don't want the hours and the minute conversion. And then we would balance this and solve. So to do that, we would divide by 0.87 and find our time, or his time, which is 192 minutes. Okay, so that may be helpful or not helpful. You should go ahead and convert that to hours and minutes, just like they gave ours, or their example. So it would be 3 hours and 12 minutes would be his previous time. Okay, but we had to use that algebraic, we had to write an algebraic equation here in order to help us. So we're going to have to take it more than that, just one step. All right. Next up, we have percent error. Kind of a fun thing to look at is percent error. Well, I think it's fun, but you know, you may disagree. All right, so let's look at this formula. So we've got a couple formulas, and you do have a worksheet tonight, so hopefully that will help with that. So percent error, okay, is when we're kind of looking at an experiment. So it's the absolute value. Don't forget that those bars mean absolute value. We're going to take the experimental value and subtract our known value, and then we're going to divide by the known value. This is also known as experimental error. So if you see the word experimental error, it's the same thing. You might use the word experimental error in science more, but again, it's the exact same thing. All right, and then we times it by 100 to get the percent. Again, if you want to get it as a decimal and just write it as a percent, that's perfectly fine too. So I'm going to change up our colors a little bit because we've changed topic a little. So in chemistry class, Jonah determines the density of copper to be 8.83 grams per centimeter cubed, while the accepted value, aka the known, right? That's another word for or way to describe known value for copper's density is 8.96 grams per cubic centimeter. Determine both Jonah's experimental error and his percent error. Okay, so this part in here, right, says also known as the experimental error. This part in here is called the experimental error. So the first thing we need to do is subtract. So his experimental error equals, okay, we're going to subtract the experimental value. Okay, so his experiment said it was 8.83. Sorry, let me get my absolute value in there. Or let's see, I don't need that for experimental error actually. I need that for the percent error. Okay, so 8.83 minus 8.96. So his experimental error is negative 0.13 is his experimental error. Now to do his percent error. All right, we're going to use the formula up here. That is the absolute value, okay, and a numerator and a denominator. The cool thing about having to find this first is we just put that inside there. It's the absolute value of negative 0.13. Sorry, the way I drew this, it kind of looks like it's all in absolute values, and it's not. Just the numerator is. Okay, and that's being divided by the known value. And our known value, or the accepted value, was 8.93 or 8.96. Geez, I have a 3 on my mind. 96. All right, so that gives me and then if you wanted to times it by 100, let's go ahead and write times 100. That's what I should have written there. Okay, so times that by 100, and that gives you 1.5%. Okay, is the percent error. Another one to think about is this idea of percent difference. Okay, it's kind of the same thing, but we're going to put our first value, it's the absolute value of the difference between the first value and the second value, divided by the average of the values. And we multiply by 100%. So let's check that out on the next page. Oh, it didn't clear out yet. There we go. All right, so example 6. Suzanne is asked to determine the volume of a cylinder using a water displacement. That's fun stuff. She arrives at an answer of 15.64 centimeters cubed. Then she measures the cylinder's dimensions and calculates a volume of 14.01 centimeters cubed. Find the percent difference of her results. So again, that percent difference is the absolute value of the first minus the second quantity divided by the average. Okay. So a few things, okay, is we need to calculate the average. Hopefully, how do you find average? Okay, average is you actually add the numbers, right, and then divide them by how many numbers there are. So we're going to add 15.64 plus 14.01 and divide it by 2. Okay, which means we're going to have 14.825. All right, we want to keep all that to start with because it terminates at 825. All right, so now we need to do our percent difference. Go ahead and do the equation and do the numerator. So it's going to be the first number. Okay, the first number that she arrives with is 15.64. So 15.64 minus 14.01. I did it again with my first absolute value sign here. Okay, divided by the average. Remember, this was our average, so it's going to go in the denominator. So 14.825. So 15.64 minus 14.01. The absolute value of that is 1.63. And we're going to divide by 14.825. You might have skipped that step in your notes or with your calculator, but that'll be okay. And that equals 10.99%. Okay, so we have the percent difference there. So there's three kind of things that you're doing, okay, on your own tonight or right now. So you've got percent change. Then we have, you want to find the experimental error and the percent error. Those are the next steps. And then the last one is that percent difference. So actually, I guess, kind of four different things that you're doing. But the percent experimental error is part of your percent error. So percent change, percent error, and percent difference. So they're very, very similar, but a little bit different. And again, you're going to have some worksheets tonight just working on using the formulas and how to apply those. All right, good luck, and I'll see you tomorrow.